Hello viewers of mine, this is another What the Physics video. We are continuing on with this whole Excel graphing 101 thing. Specifically, we're dealing with how to do this on sheets. And this continues on with the writer packet that I had been updating with the focus, as I said, on sheets. So we've already done how to linearize when we already have kind of a linear set of data. That's not, I don't really have to change anything. I'm going to scoot down here now to the non-linear trend lines. Oh no! Oh no! Oh yeah. So let's go ahead and get going. I have already taken the data and I popped it in here already. And this is time. Time is going to be on the horizontal axis because the first variable always, or excuse me, the first column always goes on the horizontal axis, and then position is going to be on the vertical axis. Now, something we kind of talked about before is, oh yeah, the independent variable always goes on the x-axis. Well, not necessarily, as we mentioned. Sometimes it just kind of depends on what we're trying to show in this relationship, because our goal with the graphs is typically to find some relationship like the slope, and it just kind of depends on what we're searching for. So let's go ahead and do that, and we'll see that it doesn't really make sense to say time is truly an independent variable, because, well, let's go ahead and chart. So there it is, and nice that it's already set up for us. We've got the titles and such. You can definitely see that this is got fixed intervals. The time is put up at 0.5 and 1 and 1. So it's definitely set up as time had the fixed values that you wanted, and then we found the position as a result. But it's kind of, could be argument made about, are you actually manipulating time, or are you just referencing time? Anywho, let's move on. Point is, we don't always have to have the independent on the x. It's arguable if there even is an independent variable here. So we don't have to change anything on the setup because it already is a scatter chart or scatter plot. But if we wanted to, we could change it by going through here. But we want our scatter plots. Boom, there it is. So I'll just jump into customize. Remember, this here would help us figure out a new title or labeling. I don't need to do that because Sheets is pretty good at doing that itself, as long as you tell it to do that, as long as you put in the axes names at the top of each column. I do need to change up the horizontal range. So what I did was I clicked on horizontal axis and scooch down to where it says minimum. I want my minimum at 0. Okay, now, do I actually have data at time 0? No, but it's often the case where we want to start off from 0, 0. Just kind of depends. I don't need to adjust the maximum because I only have 5 data points, and that is showing all of them. Do I need to adjust the vertical axis? No, because that is going from 0 to 2. But I could adjust if I needed to. I could type in the minimum and maximum, but I won't. So close that up. And now let's get serious here, right? No, let's get serious. No, stop that, fair. Stop that. Anywho, we go into series and we want a trend line. Do you want to draw a trend line? No. Enough of that. So we can see that's a nice linear line right here. It pretty well goes with the data points, but there's more to it. There's a bit of a curve. Now, I could always show the r squared value, and you can see the r squared. Remember, the r squared you want as close as possible to 1.00. We've got 0.968. That is super duper close. That's probably a lot better than most of our experimental data will ever get. But let's go ahead and do this. I'm going to change my linear into a power series, because you should always start with that, especially for the more advanced groups like the honors and AP and such. And you say, oh my goodness, oh, physics. Physics is delicious here because we have r squared equals to 1. Whoa. That's awesome. That's a great fit. But the problem is that's a curvy line. Remember, we use line and curve kind of interchangeably here. It's definitely not a linear type straight line. It's a curvy line. So how are we going to deal with that? Well, we have to linearize it. But before we linearize things, let's go ahead and adjust our label. So go from custom to use equation. And look at that, its position is equal to 0.247 x to the 2.03. That's kind of weird. So I want to, no, it's not letting me select. That's okay, I will write it off to the side. I'm just going to write down what the equation would look like. Usually I can copy and paste it, but I can't here. Physics, 0.247. And let me put some parentheses around that. Okay, and then times x, and that x is raised to the power of 2.03, whatever that means. I'll put some parentheses around that as well, just to help us visualize the different sections. Okay, all right. So that's my equation. That's my equation. Oh no, I want to have the equation on the graph. How do I get back to the graph? Double click on it. Go back to customize. Go back to series. There it is. There it is. I'm going to change from use equation, and I'm going to say custom. Okay, custom here. And I should have done this to begin with, silly. Copy that. The whole point in having it there was so I could copy it and then paste it in, right? So I got to activate the graph again. Go back to customize, series. Unfortunately, I haven't figured out where to click on the graph here to just have it pop right back up the series. So we're in custom label, and I'm going to paste this in. So there's my equation. Y is equal to mx plus b style equation. Problem is, we don't have a y-axis anymore, peeps. We've got a position axis. So I'm going to change out my y, position in meters. And then I don't have an x-axis anymore. I have a time axis. Okay, time. And then I can also say, like in seconds here. Okay. Right. I don't want it to be like the 2.03 has the units of seconds. That's kind of weird. Anywho, then the units right here, the units that go with the slope. Remember, because slope in terms of physics is a relationship between what's going on the rise and the run. So it makes sense we have units of meters over seconds. So meters per second, boom. Okay, and you know what? One other trick here. I'm going to put some extra spaces here. Okay, because that helps to separate out the r squared value. You can see that a little bit more smoothly. So this is definitely not a linear relationship. What type is it? I called it an overachiever. An overachiever. It's a squared relationship, you can also call that. But the idea is it's, the small increase here is a small increase there. But then all of a sudden, the increases just keep getting bigger, whoo, on the vertical axis. So the vertical axis is going super duper fast. It's almost like the horizontal axis, this guy here, has to do something extra in order to catch up. So how would it do something extra? Well, we can square the horizontal axis being time. They say, what? Another way to think about it, and this might be even easier for you. Look at the equation. What does it say? Time raised to the power of 2.03. 2.03 is essentially 2, right? So it's sitting here telling us, hey, take time and square it. Square the time values. Cool. All right. So what I can do is I can, let's see, not much space here. So I can say time is my new horizontal axis, but it's not time, it's actually time to the power of 2. So time squared. And then it's not going to be seconds, it's going to be seconds squared. Okay, and then I can go ahead and square each of these. So like 0.5 squared is 0.25, 1 squared is 1, and so on. But here, check this trick out. It is a nice trick. Watch this. So I select this cell. I'm going to program it to give me the square of this cell. So there, equals, I just put in an equal sign. I selected the cell, put in an equals, click on this cell, times, and then once again, click on the cell. So I just said this cell down here equals this cell, A43, times itself, A43. Enter. Hey, look at that, it did it for me. You say, did that make it really go any faster? Okay, check this out. Now I can take this formula and drag it down. Oh my goodness, oh my goodness. Because what I did was like 2.5 is equal to, squared is equal to 6.25, 2 squared is equal to 4, and so on. So I just kind of stretched out or pulled downward on the equation and made it apply to the different cells. So I'm going to do I'm just going to copy this, Control C and Control V. Boom, nice. Okay, because I didn't have to change anything on the vertical axis. In fact, I better not change anything. That would definitely screw things up. So select, and then, oh, you know what, I'm going to scroll up a little bit, and then insert, chart. I better scoot you down a little bit. Okay, oh, you know what, this looks pretty darn linear, right? Yes, but let's check it out just to make sure. So we start off in setup automatically. I do not need to adjust anything because I'm already in scatter chart. But I go over to customize. Customize, remember, I could change the axis titles and this title. But this is good. This is exactly what I want. I do want this to be like this. Position versus not time, but the square of time. Okay? Position versus time squared. And then I can double check that my axes are properly set. It already goes from 0 on up to here and 0 on up to there. But if it didn't, I would just click on right here and I could pop in the minimum for that. And then I could do the same thing for vertical. I don't need to here, but if necessary in some other situation, I could do that. It's really the only times that you're using that. But then go into series. This is where we're spending most of our time here. Let's do a trend line. Hey, nice. Okay. And in this case, because I've already linearized it, that's why this is working out so nicely. It is a line graph. Okay, and I can show the r squared. R squared is 1. Perfect. You can't get more perfect than having an r squared of 1. Oh, what if it's 1 squared? No, it's still 1. Anywho, I do need to change the label to say use equation, so that way it gives me the information. Let's see if I can clickety-click on this. Oh, yeah, for some reason it allows me to. Okay, I don't know what was wrong earlier. So I'm going to copy this. So I clicked on here and I copied the equation. And then I'll go back to, where was I? In customize. Jumped me into legend. I got to get back in the series. Okay, so this is when I have a linear fit. Show equation or use equation. I'm going to custom. There. Now, setting it up like a y equals mx plus b, just so we can say, hey, that's an equation, right? We'll deal with this little guy in a moment. Y equals mx plus b, right? But remember, we don't actually have a y-axis anymore. So we got to change it to physics terms. So we have a position axis position in meters. And then I'll put some parens around here, this number here, the 0.249, that'd be the slope. You'll learn in a little bit that that's going to be the velocity. The slope of a position time graph is the velocity. And hey, if you think about it in terms of the units, I'm sorry. This is not the slope of a position time graph. It's the slope of a position time graph squared. So it's meters per second squared. Sorry for screwing that up. Okay. I forgot what I was doing. Silly fair. Okay. This is actually getting into acceleration. I'm just going to hold off on saying any more on that. Okay. But here is the slope. Here's the slope. And it's got the correct units, meters per second squared. Meters per second squared. Okay, and we don't have x, we have what is new on the x-axis, it's time squared. Time raised 2. Okay, so now I have a position versus time squared graph. Okay, so notice I've got the units in here for the slope. That's lovely. And what in the world is going on with this? First of all, let's give some spaces there. So 4.41 e negative 0.3. That e there just means times 10 to the, right? So 4.41 times 10 to the negative 3. So that is essentially like saying this equation, position equals number times time squared plus 0.00441 and so on. So in other words, the y-intercept is not quite 0, but it's super duper close. Okay, but what I do want to put on here is the unit for the y-intercept. Remember, the unit for the y-intercept is the same unit as the y-axis. So that's going to be meters. Okay, and I put the extra spaces on here so it would help. We can see this. So I've got my equation, position, which is in meters, equals this guy right here. Okay, this is the acceleration, even though I said I wouldn't talk about that anymore. And then the time squared. Okay, so I've linearized this. It was a position versus time graph. I saw it has this curve to it, so I went ahead and linearized it by doing what it told me to do, square the time to the power of 2. So I squared the time axis. This is my new axis here. Okay, and I went ahead and graphed that, and you see it's nice and linear, and it's something that we can easily deal with. And yeah, r squared is an awesome value. That's fantastic. Pretty much what this is telling us is that there's going to be this relationship between position and time when an object is accelerating. That relationship is going to be a square relationship. So it's like if you double position, do you double time? Or if you double time, do you double position? No, there's this square relationship in order to get them to be proportional. And that's some good physics.